Asteroids populate this area of space inside the Kuiper belt, as soon as thought to be the ninth planet in our solar system. Pluto was named after Pluto, the Roman god of the underworld, but Pluto lost this standing in 2006. According to modern scientific theories, the solar system contains innumerable asteroids, a small number of dwarf planets, and just 8 planets. Our understanding of the universe has improved significantly over the past several centuries, and we have a precise idea of how planets operate, what they are made of, and whether they might also house humanity in the far future. But possibly there is still a great deal to discover about the stars in our own galaxy. What mysteries has the James Webb Space Telescope finally solved about Pluto? Does it harbor life, either known or unknown, and does it have an internal ocean? Join us as we explore the wonderful mystery of what the James Webb Space Telescope discovered on Pluto that was hidden all along. The ninth planet, Pluto, was much beloved for 76 years. People noted that it had the smallest moon in the solar system. The fact that its orbit was skewed and oval didn't bother everyone. Pluto was a bit of an oddball, but it was our oddball. Children could relate to it because it was miniature, and many adults could identify with its plight as an outcast. The populace felt compelled to defend Pluto. There was public outrage when Pluto was reclassified as a minor planet 15 years ago. It is perhaps not surprising that the International Astronomical Union revised their definition of planet, and Pluto was left off the list. According to the revised criteria, a planet must possess 3 qualities. It must orbit the Sun, it needs to be large enough that its own gravity can shape it into a sphere or something close to one, and it must have cleared any debris from its orbit. Pluto failed the third and final assessment, so we have a dwarf planet. The term planet has been used in a much broader sense for millennia. In the 1600s, when Galileo trained his telescope on Jupiter, everyone thought any large orbiting object in the sky was a planet. Even moons counted. When astronomers first discovered the rocky rocks we now refer to as asteroids in the 1800s, they also referred to them as planets. From the beginning, Pluto was considered to be a planet. It was initially spotted in January 1930 by amateur astronomer Clyde Tombaugh using photographs obtained using a telescope. Tombaugh reported his finding directly to the observatory's head. "I have found your planet X," he boasted. Tombaugh was alluding to a hypothetical ninth planet that would orbit the Sun beyond Neptune. However, things took a strange turn when it was discovered that Pluto wasn't alone in the universe. Beyond Pluto's orbit, in 1992, was an object only a tenth as wide. Since then, nearly 2,000 frozen bodies have been found in the Kuiper belt, the coldest place of the solar system's outskirts. There may be a great deal more to come. Questions were raised when it was discovered that Pluto had so many companions. What did these unexpected planets have in common with Earth? Why did they stand out? Suddenly, astronomers were puzzled about what constituted a planet. Professor Mike Brown researches planets as a planetary scientist at Caltech in Pasadena. He discovered the first Kuiper belt object seen at the time that appeared to be larger than Pluto in 2005. In commemoration of the TV show Xena, Warrior Princess, its name was changed to Xena. This icy remnant was created when the Sun and planets were very young. Brown suggested that Xena could be the 10th planet if Pluto was the 9th. But if Xena did not merit the status of a planet, then neither does Pluto. In 2006, disagreements over where to place Pluto and Xena reached a boiling point. The action culminated at a conference of the International Astronomical Union in Prague. After extensive discussion, a revised definition of planet was presented for a vote on the last day of the August meeting. Dwarf planet status was awarded to Pluto and Xena. Given its importance in shaking up our understanding of the solar system, the name is fitting. Considering Brown's work contributed to dethroning Pluto as a planet, he has earned the Twitter address at Pluto Killer. Posters and textbooks were reproduced and updated immediately, but many planetary scientists have never updated their methods. This is especially true of those who focus on Pluto. That could be sarcasm or malice on their part. But me and others argue in 2 papers that there are also valid reasons to reject the IAU's definition of a planet. The scholars read numerous books, articles, and letters to compile this information. Some of the papers were centuries old. They illustrate the multiple incarnations through which the term planet has been used by scientists and the public, and the reasons were not always obvious. Between Mars and Jupiter, in the asteroid belt, is where you'll find this issue. After its discovery in 1801, Ceres was given planet status alongside Pluto. As more objects were discovered in the asteroid belt, Ceres was claimed to have lost its planet status. Scientists had determined that Ceres had hundreds of associates by the end of the 1800s. According to the legend, Ceres lost its planetary status because it was no longer significant. This is how Ceres and Pluto were further distinguished. May's group now asserts that this is not the true story. Even until the 20th century, Ceres and other asteroids were still regarded as planets, albeit minor planets. A science publication suggested in 1951 that thousands of planets are known to circle our Sun, with the caveat that the vast majority of these planets were small fry, with sizes ranging from that of a city block to that of the state of Pennsylvania. It wasn't until the 1960s that minor planets became a derogatory term. They were discovered by spacecraft for the first time. At that point, planetary appearances were still present in the largest asteroids, but the majority of the smaller ones were odd lumps. This proved they were not just smaller versions of the larger spherical planets. The fact that asteroids often fail to escape their orbits is irrelevant to the decision to rebrand them. What about moons, you ask? Until the 1920s, they were known as planets or secondary planets by scientists. If it is surprising that, despite scientific evidence to the contrary, the common practice of regarding moons as planets persists, non-scientific media such as astrological almanacs are largely responsible for the shift. Horoscopes in these tomes are derived from the planet array alignments. Astrologers insisted that keeping the number of planets in the sky small was easier to understand. Later, though, fresh data gleaned through space exploration reintroduced moons to the planetary family, at least for some large spherical ones. Including moons, the term planet was employed again in scholarly publications starting in the 1960s. The International Astronomical Union's definition of a planet is, in brief, not the first. The word has gone through numerous definition shifts. Therefore, it might be altered once again if necessary. The IAU's definition is often defended on the grounds that it prevents the number of planets from getting out of hand. What would your life be like if the universe contained hundreds or thousands of planets? How could the average person possibly remember them all? Exactly what would we put on the lunch bags? In comparison, mere concerns that focusing on only 8 planets will discourage people from learning more about the cosmos. Perhaps in the end, the definition of a planet is subjective. In 2015, when NASA's New Horizons probe flew by Pluto, it revealed a planet with much more activity than anyone had expected. Nitrogen cliffs reminiscent of Norway's rugged coastline and methane ice shards as tall as buildings can be found on the dwarf planet. Earth is scarred by fissures deeper than the Grand Canyon and frozen volcanoes towering higher than the Himalayas. The cameras on board the spacecraft captured a large heart-shaped feature on the distant globe, which made millions of fans on Earth swoon. 8 years have passed since scientists caught that first breathless sight, but they are still seeing the world through fresh eyes. Since New Horizons was traveling at 32,300 miles per hour when it made its closest approach to the dwarf planet, it was only able to take detailed images of the side of Pluto that was facing the Sun. One of them was momentarily hidden from view by the darkness. Now that scientists have analyzed the close-ups of the near side taken by the spacecraft days before it zipped past, they are starting to look at the pictures of the other half. Scientists refer to such a region as the far side or the dark side. Despite the low resolutions, the images clearly depict the landscape with detail down to about 1 mile, at most 250 times more detailed than images captured by the Hubble Space Telescope, which orbits the Earth. Scientists now have a new perspective on this dynamic world, thanks to the analysis of hundreds of photos shedding light on questions such as whether an ocean lies beneath the icy crust, and how compounds freeze out of the atmosphere to form the planet's surface. The data even lend credence to the idea that the cold world could support life. But there are mysteries posed by the pictures. For example, the ice fragments resembling skyscrapers were only recently discovered on Pluto's far side, yet they now appear to orbit the planet. Consequently, their origins are among the dwarf planet's greatest mysteries. Richard Binzel, a planetary scientist at the Massachusetts Institute of Technology in Cambridge and a New Horizons co-investigator, says, Pluto is the gift that keeps on giving. Then, in 1996, scientists were able to see surface details at a resolution of 310 miles thanks to the Hubble Space Telescope. The images were blurry, but they depicted a planet-like globe with better global analysis than any other planet in the solar system, including Earth. In July 2015, New Horizons famously discovered a heart-shaped feature just north of the near-side's equator, confirming that Pluto is indeed a dynamic world. Sputnik Planum, a frozen basin roiling and flowing with abundant glaciers, is located within Pluto's left ventricle and is now known to have a profound effect on the planet's dynamic pulses of sublimating ice rise into the air as the sun warms the frozen plain, only to fall again when night falls. It is possible that the beating of the heart tips Pluto over. Fran Baginal, a planetary scientist at the University of Colorado Boulder who did not participate in the study, thinks it is positioned almost perfectly opposite Pluto's largest moon, Charon. The likelihood of an accident occurring is 5% at most. Instead, simulations show that a subterranean sea began to rise into the rift just as the basin was forming. Nitrogen gas from Pluto's atmosphere condensed and froze in the icy crater. Pluto's current alignment is the result of a large burden caused by the accumulation of additional water and ice. The idea of an ocean beneath the surface is not new, but the far side photos have provided significant support for this theory. Some of the most convincing evidence comes from chaotic terrain, a confusing patchwork of hills, fissures, and pits located on Pluto's opposite side from Sputnik Planum. Scientists believe that an asteroid or comet impact caused seismic waves to rip through and around Mars, Mercury, and Europa, one of Jupiter's moons. When these earthquakes finally collided at the opposite horizon, they tore the surface in a way similar to what we see on Pluto's icy moon, Charon. Planetary scientist Oliver White from the CI Institute in Mountain View, California, who did not participate in the study but created a geologic map of the far side, contends that the feature does seem to mimic ones found elsewhere in the solar system, but the resolution in the photo is low. A majority of other scientists share this opinion. Perhaps we won't know until we make a return trip. The discovery of numerous fractures on Pluto's far side, among other geological peculiarities, lends credence to the idea of a subsurface ocean and may even offer insight into planetary formation. For a long time, scientists have speculated that Pluto's ocean had a cold start, meaning it was frozen at the time the dwarf planet was formed. Eventually, the radioactive decay in its rocky core may have produced enough heat to dissolve it. This idea aligns with what scientists have found on other icy bodies in the outer solar system, such as Jupiter's moon Europa and Saturn's moon Enceladus, where subsurface oceans exist beneath icy crusts. The presence of an ocean beneath Pluto's surface would not only be scientifically fascinating, but also raise questions about the potential for life in such extreme environments. Scientists are also intrigued by Pluto's atmosphere, which is primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere undergoes seasonal changes as Pluto orbits the Sun. When Pluto is closer to the Sun in its elliptical orbit, surface ices sublimate directly from solid to gas, creating a temporary atmosphere. As Pluto moves further from the Sun, the atmosphere freezes and collapses back onto the surface. The New Horizons mission provided valuable data on Pluto's atmosphere, revealing its complex dynamics and interactions with the surface. This data helps scientists understand how atmospheres behave in extreme cold environments and provides insights into planetary evolution. Another significant discovery from the New Horizons project was Pluto's diverse surface features. The dwarf planet exhibits a range of terrains, from smooth plains to rugged mountains and icy valleys. One of the most striking features is the heart-shaped area on Pluto's surface, originally named Tombaugh Regio after Clyde Tombaugh, who discovered Pluto in 1930. This region, called Sputnik Planum, is a vast plain of nitrogen ice surrounded by mountains of water ice. The origin of this feature and its unique shape continue to intrigue scientists. Furthermore, Pluto's largest moon, Charon, also revealed unexpected features during the New Horizons flyby. Charon has a dark reddish-brown color and a rugged landscape with cliffs, troughs, and impact craters. Its surface shows a history of geological activity likely driven by internal processes. In addition to Pluto and Charon, New Horizons captured images and data from Pluto's smaller moons, Nix, Hydra, Kerberos, and Styx. These moons exhibit various characteristics and orbits, adding to our understanding of the Pluto system's formation and evolution. Looking ahead, scientists are eager to learn more about Pluto and its moons. Follow-up missions could provide more detailed observations of the dwarf planet's surface, atmosphere, and moons, shedding further light on their complex geology and potential for harboring subsurface oceans and other intriguing features. In conclusion, the New Horizons mission to Pluto in 2015 was a milestone in planetary exploration, revealing Pluto and its moons in unprecedented detail. The discoveries made by New Horizons have reshaped our understanding of Pluto as a dynamic world with complex geology, a diverse surface, and a fascinating atmosphere. As we continue to analyze the data returned by the mission, new questions arise about the distant dwarf planet and its place in the solar system.